Hey, hello everybody. I hope you had a good weekend. It's supposed to warm up a little bit here today, so looking forward to that. Let's see, in terms of announcements that we have, uh, regular announcements from last week, you can see this is the schedule for the whole rest of the semester and all the assignments and everything, due dates, all those things are in. I think that they all agree with my course's due dates. And so I don't think there's any problem there. Are they exactly the same as in the syllabus? Probably not. Because, I put the syllabus together back in December and things change and stuff and I can't go back and change the syllabus very well, but what I can do is change my courses and change my announcements. So that's what we're going to do with here. The big thing to remember, spring break, woo woo. And then right after that, we'll have the final exam. And remember, that'll be a practical exam and an objective multiple choice exam. And I'll post both of those on Monday, the 17th of March, and they'll both be due on Saturday, the 22nd. I don't think that either of them will be particularly difficult. The practical exam is really about doing things. And those doing things are going to be different because you're going to have to do them in MySQL Workbench and MySQL Server, which you're going to have either installed on your own machine, run as a virtual machine, run as a Docker container, or using a cloud-based SQL server. All good options. They'll all work just fine. You just have to choose one. And probably the easiest one is to install MySQL Server. The Community Edition is what it'll say when you install it onto your own laptop. And at the same time, you'll click another box and it'll say install MySQL Workbench. Easy peasy. Now, if you want to use something like VS Code that has an SQL extension to it, that's just fine, not a problem, whatever you want. Anyhow, those are our dates. Uh, I've got more information, for the first time in these slides about the BigQuery assignment one and the assignments in here, and we'll go over it in a second. Then right after the BigQuery assignment one, you'll have your group project proposal be due. I'll give you feedback right away from that, and then you get a chance to work on that from the 3rd until the 25th. I'm hoping that this project will be really meaningful for you, and I hope that you make it something that's really interesting to you and creative on your part. So we went over these a little bit. Last time I did a supplemental video last week, and I'm just including these. If you want more information about that, please go back and look at that supplemental video that I did. Project ideas. Well, there's a lot of good websites out there. One of them that I like is Storytelling with Data. And I think I've mentioned this one before. And let's see. So let me share that. And I think you'll find a lot of inspiration in here, and it seems like people are really doing interesting things and learning about things. I used this book when I did the visual analytics course, Storytelling with Data. I also used another book, the Big Book of Dashboards, which I also thought was very useful, and tons of different examples. So if this is something that you want to do with your life, let me just find it for you. So This one is really good book. It really goes through lots of different, really from a workmanship perspective. How do you do this? What do the colors mean? How do you organize yourself? How do you get these dashboards to work well together? So really useful, $22, not too bad. And so, you still have plenty of time if you wanted to get this book and then, help you out with your getting your dashboards together or however you want to tell stories with data. This would be a useful one. And like I said, I've used it before. Then look, it comes right with the storytelling with data, which is $26, so not too bad. Better data visualizations, all good. This is stuff that people do. The HBR, that's the Harvard Business Review, and $16. None of these are expensive. If this is something that you want to do in your career, you should start assembling a little book collection. It's only a few dollars, and even if you just page through it at night while you're watching your favorite murder mysteries, it'll be a good thing because you'll pick up ideas and techniques to do a better job of what should be a big part of your career. All right, let's go back to our PowerPoints so I can stay a little bit more organized. I know you like me to be organized. So project ideas, project proposal. Remember, this is how we're going to get started with this. This is a group project. Although you can have a group size of one. I said that before, but we'll probably I would like to have you use Azure DevOps to get yourself organized and to help you plan out how you're going to progress through this project. You've got about 3 weeks to work on it. What are you going to have done at the end of week 1? What is this member of your group going to have done at the end of week 2? What is this member of your group going to have done at the end of week 2? Who's going to pull all this stuff together to create your presentation, and then who's going to write the report? All of those things are details that can be decided very early on in the process of working on your project, and can make life a lot easier so you're not making those decisions the night before it's all due. So think about that and get yourself organized. Here's the project presentation with dashboard. You can, use this, and then your project report. And remember, this is based on the idea that you all have to do reports at the end of your master's degree. Might as well get used to doing them now. So in the Zai book this week, we're talking about normalization. We're talking about implementing things. So implementing things, how do you go from the theory to the reality? How do you make this all work? Well, one of the things that we need to do when we think about building databases that involve multiple tables is we have to think about, how do those tables relate to each other? How do the different objects that we're keeping track of, do they have a relationship to each other or don't they? Well, normalization is one of those things that we use to instantiate the relationships between tables. And the reason we do that is because we want to make sure that the objects that we're keeping track of, remember those are instantiated as tables, individual tables, and they're usually a noun, something that we have. And then we have attributes. How do we describe those objects? That's what the attributes are. Those are the individual columns, and each cell in each column relates to one object. Well, what if we had multiple ways to describe those objects? What if there was different ways to keep track of things? That's where we get into this idea of redundancy. If we have too much information in a table, then that relates to multiple objects or multiple columns that relate to one object, those are bad. That's not the way to do things. And the way we eliminate that is through this process of normalization. Now, normalization only is a concern when we're talking about online transaction processing databases. This is a key component to this whole idea of database design. What kind of database are you designing? Is it one that's going to be used to keep track of individual transactions? Josh Allen is a customer of ours. He has 2 orders with us. On the second order, he didn't get the third item in that order, and now he's pissed and he wants us to find out what happened to that third item in that order. That's an online transaction processing problem where we're interested in that one third item. You can make up the silly thing that Josh Allen would buy from us, but that's online transaction processing. Those are normalized tables, and usually normalized tables we have lots of tables in an online transaction processing database, but each one of those tables has a fairly small number of columns. The other side of database design is if you're doing online analytics processing. Now, databases are usually denormalized. We actively go through and get the information from our transaction processing databases, and we gather that all together from all of those different tables and lump it into one hugely wide table, lots and lots of columns, and lots of blank cells and empty cells and nulls and redundant information, all kinds of stuff in that one table. Why? It makes it easier to run our queries. The problem with querying an online transaction processing database is that when we have lots of tables, we have to have joins between all those tables. We need to connect from our customer table that says Josh Allen into the orders table that says Josh has 3 orders with us. And then we want to choose one of those orders and then connect it and join into that item table to find the third item on that list. And so that's 3 joins that are going through those different tables. Well, that's a lot of processing power. That's going to always slow down our databases. Analytics processing, totally different. Analytics, we generally build these analytics databases at something like 3 o'clock in the morning on Sunday night. When there's nobody in the database, we run this big query that grabs all this data from all these different tables and then lumps it into one big table. Then our analysts use that table for their 3 or 4 queries per day, and they use it for the next week until we run our big query again. And maybe we've got half a dozen analysts, but it would take a big organization to have tons of different analysts. So that's a totally different workload than our transaction processing, where with people coming in all the time and answering lots of questions. So if you look at a normalized online transaction processing database, it might be something like this, where you have lots of tables. Make it a little bit bigger. where you have lots of tables and you have lots of joins in between those tables. And, to think about it, we've got this employee table and we gather lots of information about each one of our employees. So in this case, employee is our object. This is the stuff that relates to one individual employee. And then one employee can have multiple appointments. So, and each appointment can have one-to-many customers. So what kind of information do we keep track of our customers? Well, it's right there, name, ID, date of birth, gender, contact, blah, 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 normal stuff. And then in this appointment table, the two main parts of this table are the appointment date and appointment time. When do our employees get together with our customers? That's when they come to an appointment. But here's the thing, to keep track of that, we have a primary key in our customer table of Cust ID, and we have a primary key in our employee table of employee ID. Well, then we also have this service table, whatever that happens to be, probably what service they're talking about at their appointment, doesn't matter. But to keep track of this, we have to carry those primary keys from the employee table and the customer table and the service table as foreign keys in the appointment table. Now, the appointment table is going to have a primary key of appointment ID. Each appointment has an appointment ID. Makes sense? But then we want to keep track of who's involved with this appointment. And that's where we get things like what customers are coming, customer is coming, and then what employee is going to be involved in this appointment. And then finally, what are they going to be talking about? What service are they going to be talking about? So we get these foreign keys in the appointment table because they keep track of the relations between the appointment, the employee who's scheduling that appointment, and the customer who's coming to that appointment, and the service that's being discussed at that appointment. And then our relations between these two are right in here. So if you look at the ER diagram that we have here, entity relationship diagram, which you got from the Zai book. By the way, what's the main purpose of an ER diagram? It's not for the programmers. It's not for the employees. It's not for any of those normal things that you look at. It's about communication. The ER diagram, we can collapse a ton of information. Think about how many pages this would be if somebody just typed it out by hand. Ton of information we can collapse into one drawing, which we can all just look at and figure out, boom, we're done. It's great. So it's all about communicating between all the different people involved in this database. So, as I always say in all my classes, what starts out being about technology is really about people, because that's what technology is all about. It's people. So here's our standard normalized online transaction processing database. Let's look at some of the rules of how to do this. So normalization is all about reducing redundancy. We don't want to carry extra information in our tables. Well, to do that, to kind of organize it and make it more formal, we've come up with this idea of normal forms. And normal forms, most business databases, by the way, strive to get to the third normal form. Rarely do they get to the Boy Scout normal form. And even though there are normal forms on above and beyond, or below and beyond in this case, Boy Scout, business data rarely gets there. So, this is third normal form's about as good as you get. But so, but in the And so if you think about what the first normal form thing does, these are some of the rules. So a table is in first normal form when all non-key columns depend on the primary key. We'll get to a better version of that. Second normal form when all non-key columns depend on the whole primary key. Okay? Third normal form, redundancy can occur in second normal form when a non-key column depends on another non-key column. Okay, whatever that means. And in Boyce-Codd normal form, if whenever column A depends on column B, then B is unique. Columns A and B may be simple, blah, blah, blah. We'll get to this in a second. Here's the process that you go through. When you think about normalizing a table, the way that you do that is you look at the table and your first question is, am I in first normal form? And I'll give you some rules for doing that. And let's go on and do that first. So normalization process in regular words. I like regular words. So start with first normal form, then progress to second, third, and finally Boyce-Codd. Am I in first normal form? Yes. Okay. Am I in second normal form? Yes. Okay. Am I in third? That's the process. And to simplify those descriptions of the different normal forms, think about it from this perspective. If you have a valid primary key, if each row is unique, you have a valid primary key, you meet the other rules of tables too, not only one item per cell, all those basic rules. If you have a valid primary key, you're in first normal form. So what that means is that it's easy to get to first normal form if you use that artificial auto increment, means nothing, normal primary key. That gets you to first normal form really quickly. If you have a simple primary key, one column, meaningless, and artificial, so not combined columns, not first name, last name as primary key, just customer ID. If you have a simple primary key like customer ID, then you're in second normal form. Congratulations. And then to get to third normal form, if you don't have any dependencies between non-key columns. So here's an example of a dependency between all non-key columns. All of the brown cars have the luxury option. The problem there is that we've got redundant information. If it's enough to say that a car is brown, to know that it has the luxury option, we don't need to include the information about the luxury option. It's redundant. If we have a dependency between the color of the car and the options that that car has, all the red cars have the sports option, then sports option is redundant. You probably always have to include the color of the car, but you don't have to include the option. You don't have to have a binary field that says sports option yes or no, because if it's red, it's got it. If you don't have that, then you're in third normal form. And you're in Boyce-Codd normal form if there are no dependencies between any columns. Same as the third normal form, except remove non-key. So if every car that starts with the letter H is green, should use like B and blue or something, but whatever. There's a primary key that starts with B, then the color of the car is blue, then why include the column that says car color if you've already got, R for red cars and B for blue cars and W for white cars? If you don't have any of those dependencies, then you're in Boyce-Codd normal form. So, the academic version is tricky to read and hard to figure out. But if you just think about it, it makes sense. If what we're trying to do is to avoid redundant information, then we only want to include that information once. And that's what all these rules are really all about. If if every one of our passengers to Chicago is in the economy class because that's the only seats that we have in that airplane, why include economy class? We already know if they're going to Chicago, it's economy class. Those are the kinds of questions that you have to ask yourself when you think about normalizing tables. Now, I hope you can see where this only applies to transaction processing, because that's where these questions come up, where we're keeping track of individual things or individual transactions. But in an analytics world, it's just different. Nobody uses an analytics processing table to find out about Josh Allen's third item from order number 5. You don't do that. It's just not what that table's for. So that's normalization. We've got some other things in here. Let me share this. Yeah. So implementing entities, that's a big question. And, write this down. If you want to take any single sentence away from a database class, here's the one. If you have a one-to-many relationship between two tables, the foreign key goes on the many side. And the foreign key is going to be the primary key from the one side. So the primary key from the one side gets stored as a foreign key on the many side. There, we're done with class. Yeah, so that's implementing entities and implementing relationships. First norm is okay, Boy Scout, blah, blah, blah. The MySQL architecture part, this is about the DDL and the DML and the way that MySQL works. And it's interesting because it has a layered architecture. It's well designed. It's got this storage engine. It's got a file system, which is different. I teach a storage architectures class, and everybody's always amazed that a database management system doesn't use a file system. It has its own. And because it doesn't store things as files, it stores them as records. And so it's just different. So there's that. And let's see. So yeah, this is about the tools and APIs and connectors and all those kind of things. Our query processors, our query parsers. And so this is all about the background stuff of how to work with MySQL. Now, the other thing that we have in here are these different kinds of databases, and this is huge. It's a big deal, and because in the old days we only had a small number of databases that we could use to do everything, but now there's lots more, much more specialized databases, and you see them more in cloud-based implementations than you do in local-based implementations. Why? Cloud just makes a lot more sense for all this stuff. If you have a huge architecture that you can use to replicate storage around and about with just a click of a button, why not? Why not do it? Yeah, it costs more money usually than doing it locally, but you know what? It's worth it. So those cloud-based databases are really important. MongoDB and And there's lots of different ones, but anyhow, replicating databases, and we do this all the time. Standard architecture for some sort of a web-based system is to have um, um, multiple databases that store our information. One of which is our source of truth, and most of the time when our users are browsing in our e-commerce applications, they're accessing data that's old because we have them browse using a replicated database, an older version of our primary source of truth database. And then when somebody goes to buy something, they click on the, buy it, and that transfers them over to the source of truth database and gives them accurate things like accurate pricing and accurate inventory levels, because those replicated versions of the main database, they're out of date. We know that, everybody knows that. And the places they become out of date are things like inventory levels and pricing information. So anyhow, that's replicated databases, data warehouses. This is when we go from transaction processing databases into analytics databases. Data warehouses, warehouse designs, all that kind of stuff. It's all about going from transaction processing to analytics. And we talked about that a lot. So that's it for this week. Next week, we have our database programming section, and that's it for the iBook. So we're almost done with the iBook, and there you go. So, okay, I gotta stop this here and go back to my PPTs. Come on, little feller. Okay. So BigQuery, we need to start getting into BigQuery, and this is your information for your BigQuery assignment number one. We're not going to have a lot of time to talk about this. You're really going to have to figure this out on your own, but I don't think you'll have any trouble with it. So we're going to be using the analytics sample database for our BigQuery assignment number one. It's an e-commerce database, and we're going to be answering e-commerce kind of questions. Why e-commerce? You guys should all know something about e-commerce. The odds are good that a lot of you are going to end up working in an e-commerce environment. And if you haven't done that yet, you're going to find it pretty amazing, the information that exists out there. And the Google Analytics sample database data set is out there. We've got a BigQuery Kickstart, which is just a really quick version to get into BigQuery. Then we've got our BigQuery Cookbook, which is going to be your reference for the BigQuery assignment number one. You'll see what I mean. When you compare the assignment to the BigQuery Cookbook, you'll find that some of the queries that they have in the BigQuery Cookbook are pretty close to the ones in the assignment, but you got to change a few things. And, I'm okay with that because that's how you learn. Data Studio is out there. I think I've got these open as tabs. Let me just do that. Okay, so here's our introducing the Google Analytics sample data set for BigQuery. I think you'll find this really interesting. Old, but interesting nonetheless. Let's see, this is the legacy version. I want the other version. Is right here. Google Analytics 4 is replace Universal Analytics. This is really cool because Google Analytics is one of those things where if you've got root access to a website, you can just take a little chunk of code that Google has, plunk it into your pages, and your web server will report back all this information to Google, and you can have your own data set of all of that will allow you to ask all these different questions. So fascinating stuff. If you have access to a data set, take advantage of it. It's really cool stuff. Google knows everything about us anyhow. What more can they get, right? And let's see, data set with Cloud Console. So, how to work with the Cloud Console. All right, there's that one. Here's my Looker Studio interface, and it's pretty easy to work with. And these are just a bunch of reports that are shared with me. These are some of the reports that you can do in BigQuery. Oh, this one I included because it's about data sets available from Dubai. So if you want to think about Dubai and some of the information about, that big, fascinating, well, it's tiny, but fascinating country, there's a lot of data sets that are out there that you can just access for free and see what you think about them. And, well, we already looked at this one. Let's go back. And so here's your BigQuery assignment number one. It's going to be fun, blah, blah, blah. Here's your BigQuery cookbook link. Good place to start for this project. Like you to not only make the queries run, but I also like to try to understand what you're reporting. As we discussed in class, you can export the results set that you get from your queries into Looker Studio, and then use that to create displays of what you've found. And you can work with other people to accomplish this, but everyone should learn how to do it. So if you want to use this as a kickoff for your team to get used to working together, which is always a good thing, fine, do it. Just make sure that everybody knows what's going on. This is how you're going to learn how to work with BigQuery if one person does the whole assignment because, hey, this is fun, then the other people aren't going to learn it. And so when they get to the group project, they're going to say, I don't know how to do this, but, I'll help out if I can, but I don't know how to do it. And then these are some of the questions. These are the questions for you to answer. Things like the total number of transactions generated per operating system. What do your users use for an operating system when they access your e-commerce site? The real bounce rate. Well, that's a lingo thing that only e-commerce people know what it means. Well, you know, we'll talk about this some more, but I just wanted to post it out there for you to get a look at it. And you can look at it. I'll post the PowerPoints also, and I'll probably make it as a part of the assignments in my courses also. But these are the kind of questions that I'm going to want you to answer as part of your BigQuery assignment number one. It's going to use the Google Analytics data set, which is based off of the Google Merch Store. And we'll talk about all those things again in the future. So just a little waker-upper for you here, and you got lots of time, no rush or anything. That's it for this week. I hope you have a good week, and I will talk to you soon. Take care, everybody. Bye-bye.